Okay, can we restart here? Looking ahead to question number 5. This is just to re-emphasize to us this change of base rule. So if we were going to rewrite this in base 10, how could we rewrite this logarithmic expression? Yeah, Gernot. Yeah, log of 100 over the log of 2. And then we could just plug that into the calculators. Log of 100, though, remember this is a common logarithm, so it's base 10. So what is the log base 10 of 100 equal to? Without a calculator, yeah? Yeah, because this is going to be 100 is a 10 squared, right? So this will be the same as, don't need the logarithm, we know that's just a 2, over log base 10 of 2. And the denominator we will need the calculator for. So if you plug that in, what do we get to 3 decimal places? Chantal, do you have it? 6.644, and what's behind my happy face? Hey, I got the same thing. Yay! Okay, and is everybody comfortable with entering a log of a different base on their calculator? Everybody knows how to do that? Well, your calculator doesn't do it, James, sorry. That's this one. Yep. So this is how you would have to evaluate it using your calculator. Okay, next page. So we have an application question. Jade has a balance of $3,625 in her savings account, pays 2.2% interest per year, compounded annually. Here's the formula. So remember, A is the future amount, P is the principal or present amount, I is the interest rate per compounding period, which in this case will be per year, and N the number of compounding periods. We want her balance to reach 5,000. So that's going to be the future amount. And we want to know how long is that going to take. So what we don't know is the N value. The interest rate, since it's compounded annually, that will be 0.022. So again, write the interest, the percentage in decimal form. And then we know her initial amount, which I can't see again. Principal is 3,625. So we solved problems like this by graphing back in the previous chapter, but now we want to do it using logarithms. So we need to enter these values into our formula. And we can solve for the n in the exponent. So here, if we were graphing, we could just enter left side is L1, right side is L2. But if we're going to do it algebraically using logarithms, we need to get rid of this 3,625 by dividing it on both sides. And on the left side, I could simplify it or I could put it in decimal form because I'm not working on a calculator right at the moment. Instead, I'm just going to leave it as a fraction. And then the right-hand side, I'll simplify what's inside the brackets to a 1.022, and that's to the exponent n. Once we get to this point, we have two choices for how to solve this. One way would be for us to take the logarithm of both sides. And with my minimal space here, I'm not sure how I'm going to fit two ways in here. Maybe I'll just start shrinking things. So we'll say this will be one of the options where I'll take the log base 10 of the left side and I'll do the log base 10 of the right side. And then we can use that law of logarithms that says if I have a power raised to an exponent, I can multiply the exponents. And remembering this whole logarithm is an exponent, that means I can bring the n down in front times the log of 1.022. And that will equal log of 5,000 over 3625. Everybody good up to there? Now we finish off, remembering our goal is to find out what n is, so I need to divide out this log of 1.022, and we'll divide it on both sides. So that will give me, I'm running out of space, but my n value will equal that calculation. So this we can plug into our calculator no matter what type of calculator we have. Even a small scientific calculator, you can do logarithms base 10 on it. And so we could evaluate this. And maybe I'll just drag over my answer here. 14.8 years. So I'd encourage you to do this calculation with the log of 5,000 over 3,625, all divided by the log 1.002, 1022. Are we getting 14.8? Okay, good. So that's one option for solving exponential equations using logarithms. And this is the most common method that's taught. And if we got into more complex questions than we need for this course, this would be the option that we would pretty much always do. But because for this course, we're only going to have a variable in one of the exponents, we have another option. And our other option, just thinking about how to use my space well here, let's group this. Let me just shrink all that beginning stuff. Okay, so I'm going to work from this equation. Let's go with So from this equation, what I could do is I could rewrite this in logarithmic form. So again, I start by saying, oh, here's my base. So I'm looking at a log base 1.022, which is kind of an unusual number for a base, but it's perfectly fine. We're just using the rule of how we rewrite from exponential to logarithmic form. The logarithm operates, well, it gives me an exponent as my answer, so my answer will just be n. And it operates on this power, and this is equal to the power over there. So I just have the 5,000 divided by 3625. So if your calculator will do logarithms of other bases, you could type this in exactly like this. And so if your calculator will do it, try that out. Again, you should get 14.8 years. If your calculator doesn't, James, and maybe somebody else, yeah, Carmen. So then you're just rewriting it like this. You're using the change of base rule to rewrite it in the same form we had here, where we have the red over the green. Everybody's getting 14.8 again? Good-o. So you have a choice of doing it either way. The one thing I'd say is it's good if you understand both ways, because again, for a multiple choice question, answer could be written in either of these forms and you need to be able to recognize it. Any questions with number 6? Nope. All right. I think maybe I should let you try number 7. Similar idea, this time working with half-lives. I'll give you a couple minutes to read it and see what you can come up with. So I'll start writing up my solution here. So I need to start by dividing the 500 out first. Did anybody rewrite this in logarithmic form? So did everybody just take the logarithm of both sides? Is that what we did? James, did you write it in logarithmic form? Okay, so either way we can do it. Why don't I take the log of both sides? So the logarithm of the left and the logarithm of the right. And once you do a number of these questions, it'll become fairly automatic that as soon as we take the logarithm, we can bring that exponent down in front. So just to save some time and space, I'm going to bring that 19 over h down in front to multiply it to the logarithm right away. Then because my goal is to solve for h, I'm going to multiply both sides by h so that I get it out of the denominator into the numerator. And again, as I look at my limited space, I'm going to divide this log of 13 over 500 on both sides. It kind of looks like a mess initially, but these will cancel out here and these h's cancel out there. So I just end up with h is equal to 19 times the log of a half all over the log of 13 over 500. So if we were looking for an exact value solution, that's what our solution could look like. Michelle. I could divide the log of a half, but because my h was in the denominator here on the right-hand side, I wanted to get that out of the denominator, so I multiplied it to the other side. If I divided by the log of a half, then I still have 19 over h, and no, because it's already in the numerator. So I'd have to divide out the 19. Instead, once I got to that point, I might take the reciprocal of both sides, because I want to get the h into the numerator somehow. So my final answer is about 3.64 days. Anybody else get that? A few people did, a few people didn't. Anybody have questions, or do you need a minute to look it over? Simran. The other way, let me just hold off for a little bit to make sure everybody understands this, and then I'll go through it the other way. Let me give you a minute just to double check your work, and I'll wander around and see if you have any questions. So it sounds like there's a mistake in my answer here, so we'll have to fix this. This would round to a 1, right? So 3.608. Okay. Good. Thank you. I guess this means I owe Kaylee a candy. I'll move horizontal. There we go. So that should be the answer. Okay, let me go over the other method. Again, my first step would be the same. So I'll divide the 500 on both sides to get 13 over 500 equals 1/2 to the exponent 19 over h. Then I'm going to do the logarithm. My base in the power is 1/2, so my base in the logarithm is 1/2. The logarithm is equal to an exponent, so it's going to equal the 19 over h. And it operates on the power, and this is equal to my power, so here I'll have 13 over 500. Again, we have this challenge where the h is in the denominator, so we have a couple choices that we could think about. If we think back to the sinusoidal functions, and when we looked at period, we discovered that we can just take the h and multiply it up there and divide this whole logarithm down on the left, or I should say on the right side. And if we do that, we'll get h equals 19 divided by the log base 1/2 of 13 over 500. And then that we could just plug into the calculator. Okay? All right, let's go on to the next page, which will be the next video.